next week looks like. Just a heads up. Eyes here. We're going to do 7-5 today, 7-6 tomorrow, 7-7 on Thursday. That's the end of the chapter. These amp up what we've been working on. So on Friday, I put a scramble of these three together for here. Okay? Monday is going to be an online review. Tuesday is an online test for chapter 7. Then we're going to start chapter 8. Just a heads up, next Tuesday is March 1st. Okay? So you're going to have a quiz on Tuesday. Conferences are on the 15th. The end of the quarter is the 23rd. And you guys know, as far as calculating your grade, you want your quarter grade as high as you possibly can. And I will tell you, in quarter 4, we don't have as many points. Even quarter 3, we've only really had chapter 6 and now chapter 7, right? And quarter 4, we'll have chapter 8 and part of chapter 9. And then we have April where we're testing, so there's not a ton of points. So I'm just telling you, you want to be taking care of every single point possible that you can. Speaking of that, if you know you're going to be gone, whether it's 1 day or 7 days in April, please let me know ahead of time. I don't want testing to be a stressful thing for you. Okay, I don't want it to be stressful for you. So anything that I can eliminate ahead of time would be fantastic. So if you know you're going to be gone, let me help you out. All right, let's get into what we're working on today. So last week we dealt with exponents, like understanding what an exponent was, understanding our exponent laws. So now we're going to go into how does this really get into the algebra aspect of things. So 7-5 is exponential functions. Remember, functions is a fancy word for equations, right? So it says an exponential function is a function written in the following form. Y equals a times b to the power of x. Now notice, your variable is in the exponent. In order to write this, we're going to replace a and b with the appropriate numbers. So your base is constant, but your exponent is a variable. Exponential functions are nonlinear, not a line. They are a curve. Remember, functions are linear if they have a constant rate of change. I don't have a constant rate of change here. So what does this look like? Here's an example of an exponential function. G of x is just a fancy way of writing y. Y equals 1/4 to the power of x. Now, if I wanted to write it, technically, that'd be like 1 times 1/4 to the power of x. Does that make sense? Technically, they could have a number. In this problem, they don't. So they just want us to get used to, how do we even calculate this? How do I work with it? So the first thing, they're just going to have us fill out a function table. And this is where people want to use their calculator, and it actually hurts them more than it helps them, because they don't want decimals. I don't want decimals. Okay? So let's use this as workspace. The first number they want us to plug in is -2. So we take this and we say 1/4 to the -2nd power. How do I evaluate what 1/4 to the -2nd power is? Patrick?
Well, it's like thing is a negative or whatever.
Yep.
Well, first you have to put it on.
Okay. So it'd be like 1 to the -2nd and 4 to the -2nd.
Yeah.
Okay.
And then you have to switch them around.
And why? You're right, but why?
Because it's a negative.
Very good. The negative exponent says move its location. So really 4 squareds in the numerator, 1 squared's in the denominator.
And then you just solve. So 4 squared is 16, and then over 1.
Which really is just very good. Everybody follow what he did there. Okay? Because that exponent is negative, let's look at the next one. I'm going to show you a tip here. Okay? 1/4 to the -1st. When I see that negative out here, what I do is I just flip everything on the inside. So instead of 1/4, I really have 4/1, or in other words, 4 to the 1st power, which is 4. Then I take 0. 1/4 to the 0 power is 1. Nicely done. 1/4 to the first power. 1/4 to the first power. 1/4. 1 to the first, 4 to the first is just 1/4. 1/4 to the second power. Very good. 1 squared and 4 squared, which really is 1/16. So putting this in your calculator, if you put 1/4 squared in your calculator, it's going to give you a big, long, nasty fraction. Or decimal, I mean. We don't want decimals. The biggest thing that's going to be, you're going to have to be careful of is watching for that negative exponent. Negative exponent doesn't make it negative. It makes you switch its location. Questions on how to evaluate? Okay. Now, they're going to go the opposite. They're going to give us a table and tell us to write the equation. All right? So we start with y equals a times b to the power of x. And I'm going to have to evaluate what a and b are. I can't have an a and I can't have a b. They're going to be numbers. So the two places you start, the first place you start is plugging in 0. This is the first thing you do. They tell you that if you replace x with 0 and y with 8, okay, so take your equation. Y is going to be 8. I don't know a, I don't know b, but I know x is 0. Now, why would I want to do that? Why is that going to help me? Caden? Very good. Now be careful. The whole thing is 1, right? So b to the 0 really turns to a times 1. Well, what's a times 1? A. So what did we just calculate? We just got the first half of our equation. Everybody follow me? I'm only part way done, though. So that's step 1. So now at this point, I know it's y equals 8 times b to the x power. I don't know what b is, though. So for the second part, use your x value of 1. Plug in 1 for x and 32 for y. So 32 equals 8 times b to the first. Well, what's b to the first? B. So really this is 32 equals 8b. Then what do I do? Divide by 8. B equals 4. So my final answer, what is my exponential function? Y equals 8. Put the dot for times 4 to the x power. Now, sometimes they'll have you put parentheses right here, which would be fine as well. But I usually just put the dot in between the 8 and the 4. But be careful, you don't want it to say 84. Plug in 0 because it's going to make your b turn into a 1, and then plug in 1. So you're still like, okay, I think I'm okay at this point. Now we're going to graph them, which is why they have you practice even calculating it. And if you read carefully, it says graph the exponential function g of x equals 4 to the power of x. To graph the function, plot the points on a graph with these x values, then click the graph icon. The graph icon is this button right here. They tell you exactly what they want you to plug in, okay? Every single problem today, if you're going to graph, you're going to plug in -2, -1, 0, 1, and 2. So if I'm going to make a table, I'm going to need some workspace here, but I know I'm going to need -2, -0, or -1, 0, 1, and 2. Make sure you're on the top. Make sure you're on the top. On your own, plug in those 5 points. Plug those into this equation. G of x equals 4 to the power of x. Fill in that table. Okay, so if I plugged in a -2, 4 to the -2nd, what do you end up with? Very good. This is really over 1, means you got to move your 4 squared. You wind up with 1/16. Nicely done. If I plug in a -1, what do you end up with? 1/4. Excellent. If I plug in a 0, is 1. If I plug in a 1, 4. And if I plug in a 2, 16. Okay. Now, the bottom 3 on this would be easy to graph. Agreed? But you don't know how to graph the 1/16, or I shouldn't say you don't know how. You don't know where to graph the 1/16 and the 1/4. So I opened up an Alex assignment so we can talk about this. Okay? I absolutely agree that you could go 0, 1, 1, 4, 2, 16. And you have those points. But you need to be able to use your plot a point. Okay? When you did your plot a point, -2, what did you calculate? 1/16. Tell it to plot it. It will put it on there for you. -1 gave you 1/4. Tell it to plot it. Now, as you can see, there are 5 points on that graph. See all 5 of them? 1, 2, 3, 4, 5. And we talked about this as nonlinear. This is where you then hit this graph of function. Ooh, that's not right. If it does that, you're wrong. -2 was 1/16, right? And -1 was 1/4. 0 was 1. 1 was 4. 2 was 16.
Does the order matter? Like if you put it.
No, it shouldn't. -2 was 1/16. -1 was 1/4. 0 was 1. 1 was 4. 2 was 16.
Try checking it.
Well, it's not going to be right because it's the wrong function. Plot 5 points on the graph, then click the graph of function button.
Is it only right if it's yeah, because it's not the same equation.
Let's see here. It should still graph it correctly. So -2 would be 1/4. -1 would be 1/2. 0 would be 1. 1 would be 2. 2 would be 4. Okay, this is what it should look like. I don't know why that other one's not working. It apparently doesn't like that. But that's a good sign. Here's like the beauty of using Alex. If yours isn't a nice smooth curve like this, every single time you screwed up. Okay? It's a good indication you screwed up. My favorite is like, I know I graphed it right, and I go and their graph looks like our last one. And it's like, no, you didn't graph it correctly. Okay? That one's pretty straightforward. The bottom one amps our game up a little bit. Okay? We're still plugging in -2, -1, 0, 1, and 2, but we have to follow our order of operations. Okay? So if I plug in -2, I have 3/2 times 2 to the -2nd. What should I do first? Very good. Really, this is 2 over 1, right? And because it's a negative exponent, we need to flip what's inside. So this is 3/2 times 1/2 squared. Notice my squared became positive now. Okay? 1/2 squared is 1/4. Now I multiply across, right? I end up with 3/8. So my problem is my point is -2, 3/8. Try -1 on your own. Plug in -1 for me. I got 3/4. 3/4? Okay. There's my next point. Plug in 0. It is not 1. It is not 1. 2 to the 0 is 1. This absolutely becomes 1. But then you have 3/2 times 1, which is 3/2. Plug in 1 and 2 on your own. I got 1, 3, 2, 6. Okay. Now let's see if this will actually work. Okay, so what was it? -2 3/8. -1 3/4. 0 3/2, right? 1 was 3 and 2 was 6. And then I hit that graph. It's not going to work because this is not the right problem. But it should again give you that smooth curve. Apparently you're right. It's a great question. You're welcome. It should. I'm in as a student right now. Okay, the last part about this is something that's called an asymptote. Okay? So an asymptote in math is an imaginary line that your graph never crosses. It gets infinitely close to, but it never crosses. So if we look at this, we have a horizontal asymptote at this dashed line. Everybody follow me? So this line, and you noticed it on our other problem, on problem 4, technically we had a horizontal asymptote there too. This graph is getting ever so close to this. Notice it went from like 1/4 to 1/16. It looks to the naked eye like it's going to be right at 0. It is never going to touch 0. It is going to get microscopically close, or what we call in math, infinitely close. It's going to get like 0.00000000001. It's going to be right above that. And that's called an asymptote. So if I go back to problem number 2, I think that's the problem it was. So in this problem, it's getting ever so close to that horizontal asymptote. So the question is, I need the range and the domain. Now we have to remember what range and domain mean. Range, yeah, they're your x and y. Which one's which? Range is y, domain is x. So when I look at this, or every time you look at a problem today, which one's going to be easier? Which one has no restraints? We're talking domain and range. Meg informed us domain is x, range is y. When I look at this graph, which one's not going to have any problems, x or y? It touches all your numbers? It touches all your x's?
No.
You're guessing. You're guessing is my point. If I continue this on, is there any reason that it will stop at any x? Could I technically plug in -3,000? It's going to be a long ways up there, right? So in this case, your domain is all real numbers. There is no restraint on what x values you can plug in. What is the restraint on my y values, though? What about 2? It can't be 2. It can't be less than 2. Can it be 2? No. So if it can't be 2 and it can't be less than 2, we have to write this using an inequality. So range is what letter? Y needs to be just greater than, not equal to? Very good. Greater than 2. So you're looking at where can my graph occur? Hint, hint. Are you listening? Domain always works. Domain is all real numbers all the time. It's your range that's going to have issues because of where your asymptote is. There's one more problem on here I want to look at. This right here. This is reading a graph. Water is placed in a bottle inside a refrigerator. The water temperature in Celsius after X degrees is modeled by this function. So 0 minutes all the way up to it's 45 here. And this is the temperature of the water in the bottle. The graph of the function is shown below. Use the model to answer the parts to the right. What is the y-intercept of the graph? 20. Oh, yeah, we do have to put a number there. What does it represent? The minimum temperature, the initial temperature, or the initial time? Initial temperature. 0 minutes, it is this degrees Celsius. For the first 30 minutes, as time increases, time is on your X, the temperature decreases. Give the equation of the asymptote. Y equals, at what Y value is your dashed line? 5. Choose the statement that describes the meaning of the asymptote. The temperature of the water does not fall below 5 degrees Celsius. The water cannot be in the bottle for more than 60 minutes. The temperature of the water does not rise above 20 degrees Celsius. The first one. Now, is the last one true? It's true, but it's not because of the asymptote, right? Okay, so you got to answer based on the asymptote. And then we'll hit the check, fill in all the empty boxes. Oh, thank you. I was like, I thought I did. Okay. So, as Mason said, how can you get these wrong? You shouldn't. It's going to graph it, Goofy. It's going to graph it. On this problem, do you have any work to write down for me? No. But on when you're plugging it in, you absolutely do. Go to work. On like a problem like this one, you're not going to have anything to write down.